Okay, using the second fundamental theorem of calculus to find f prime of x. So question number 1, we have f of x is equal integral -2 to x t squared minus 2t and dt. All right, this is going to be equal, using second fundamental theorem of calculus, f prime of x is going to be equal x squared minus 2x. Okay, so we're practically taking this expression f of t and replace this t with x. Why is it happening? You can look previous video where I explained the second fundamental theorem of calculus to find derivative. Okay, question number 2. F of x is equal integral from 1 to x t squared plus 1. One thing you need to remember, it's crucially important that the function has to be continuous, right? Function has to be continuous and not have any break, which is the same way here. So continuous meaning domain is going to be negative infinity to positive infinity, right? So it's not going to be 0 in this case. In this case also, the domain is going to be from negative infinity to positive infinity, because t squared, it never can be negative or 0, right? Because it's going from positive 1 to x, which is x is going to be function. So at this point, we won't have it 0 as a 0. All right? Therefore, we can apply second fundamental theorem, and which says if you have continuous function on the open interval, then derivative is going to be equal to original integrand, and replace t with your x. And here we're going to have x squared over x squared plus 1. Now, if it would be, let's say here, minus 1, that would be different story, right? Because at the second t is equal 1, right? Then it's would be 0, and we wouldn't be able to apply the second rule, second theorem. Okay, question number 3. And the other important function is, important condition is, here you have the constant, and here you have variable, which represent function of x. Okay. Question number 3. F of x is equal integral from -1 to x square root x t to 4 plus 1 dt. So from here, f prime of x is equal square root x to 4 plus 1. Yes? Okay. Next one, we have number 4, f of x is equal integral from 1 to x, and we have t squared plus 1 dt. Okay, so f prime of x is equal x squared plus 1. Okay, moving to next, number 5. So we have f of x is equal integral from 1 to x, radical degree 4 of x, of t, I'm sorry, dt. And f prime of x equal radical degree 4 of x. Okay, now let's solve question number 6, where f of x is equal integral x to x plus 2 over 4t plus 1 dt. So here we have our boundary are two functions. Here is a function of x, here the upper boundary function of x plus 2, right? So therefore we cannot apply the theorem of calculus. Therefore we are going to use the following. So it's going to be 4t squared over 2, and from x to x plus 2, and then plus it's going to be t, x plus 2, and x. So if we plug it, so this is going to be gone, and here we will have 2, and the result is going to be 2x plus 2 squared, right? Plus, minus 2x squared. Okay, now we are going to work with this t plus t. It's going to be plus, instead of t plugging x plus 2, and then instead of t plugging minus x. Okay, so now I'm going to open this twice x plus 2 squared, which is going to be 2x squared plus 8x plus 8 minus 2x squared plus x plus 2 minus x. Okay, 2x squared, negative 2x squared is gone, plus x minus x is gone, and we are getting 8x plus 10, and the derivative f prime of x is going to be equal 8. Now, there is alternative to this solution. So I'm going to manipulate the way so I can apply second fundamental theorem of calculus. Let's do it. F of x is equal integral from x to x plus 2, 4t plus 1 dt. Okay, this is equal, all right, I'm breaking down between x and x plus 2. I can't have on both boundaries as a function, so I have to have one constant and then one function. So I'm breaking down as an x to 0, 4t plus 1 dt, and then plus integral from 0 to 4 integral from 0 to x plus 2. Okay, 4t plus 1 dt. Okay, so from here I'm going to switch the positions, so bring constant to low level and x is going to be upper level, but we are going to pay for it with negative sign. So 4t plus 1 dt and plus integral 0 to x plus 2 4t plus 1 dt. Okay, so we have all conditions there. The function is continuous. There is no interruption in the function, and we have constant and function on the boundaries. So we can apply second fundamental theorem. It is going to be f prime x derivative we are going to find from here. F prime of x is going to be negative 4x plus 1, right? And then plus, since we have, instead of x, we have x plus 2, we are going to plug, instead of x, it's going to be x plus 2. Since we have there 1 and plus 1, so we're writing down plus 1. And if you add and calculate, you are going to get 8. Okay, let's do next one. Number 7. So f of x is equal integral from negative x to x. And that is going to be t cubed dt. Okay, so I have negative x, I have both boundaries, I have function. So to find the derivative from here, I have to take integral first, t to 4 over 4, and plug x and negative x boundaries, and this is going to be equal 0. Okay, let me solve it. 1 second. Let me plug it in. It's going to be x to power 4 over 4 and minus negative x. Okay, let me write down better way. Negative x to power 4 over 4, which is going to be equal x to power 4 over 4 and minus, since negative x to power even degree, it's going to be but end up positive x to power 4, right? And we are getting 0. All right, so now let's do alternative solution is using second fundamental theorem. So this is going to be, let me separate here, we solve here. So f of x equal integral from negative x to positive x t cubed dt is going to be equal integral from negative x to 0 t cubed dt plus from 0 to x t cubed dt. All right, so it's equal negative sign, switching boundaries to negative x t cubed dt and plus from 0 to x t cubed dt. All right, So from here, now we can apply, right? And it's a continuous function. So derivative f prime of x is equal negative x to power 3 times -1, right? And plus x to power 3. Well, plugging 0, I dropped because it doesn't make sense, right? Okay, and the answer is going to be 0. All right. Okay, in number 7, I forgot to write down f prime of x is equal 0. Okay, all right. Number 8, f of x, we need to find derivative again, given f of x is equal integral from 0 to sine x square root of t dt. Okay, so this is going to be equal 2/3, so it's going to be, okay, let me rewrite this way, from 0 to sine x t to power 1/2 dt. And from here we are going to get, so t to power 1/2 plus 1, it's going to be t to power 3/2. I'm going to write down this way, t to power 3/2, and divide it. When we divide by 3/2, it's going to be times 2/3, right? Okay, and here we have sine x upper boundary and 0 low boundary. And this is going to be equal 2/3 sine x to power 3/2, right? And derivative f prime of x, it's going to be equal sine x to power 1/2, right? We're taking derivative, and times derivative of sine x is going to be cosine x. Okay, so this 3/2 when come in front, it's going to get cancelled, right? Okay, and 3/2 minus 1, we get 1/2. Okay, so, and the answer is going to be cosine x square root sine x. Okay, now let's use alternative method solution. Okay, f of x equal integral from 0 to sine x square root t dt, and derivative is equal, so it's going to be square root sine x, right? And then dx of sine x, right? Chain rule, which is going to be equal cosine x, derivative of sine x cosine x, and square root of sine x. Next, question number 9. So f of x is equal integral between 2 and x squared, and we have t to the power -3 dt. Let me rewrite one more time so it would be clear. Okay, so this is going to be equal t to power negative 2 over negative 2, right? And we have x squared and 2. Okay, so let's replace x squared to power negative 2 over negative 2 minus 2 to power negative 2 over negative 2. And we are going to get, next, question number 9. So f of x is equal integral between 2 and x squared, and we have t to the power negative 3 dt. Let me rewrite one more time so it would be clear. Okay, so this is going to be equal t to power negative 2 over negative 2, right? And we have x squared and 2. Okay, so let's replace x squared to power negative 2 over negative 2 minus 2 to power negative 2 over negative 2. And we are going to get x to power negative 4 over negative 2 minus 1 over 4 times, well, negative 2, and so which means it's going to become positive, right? And the answer will be 1 over x to power positive 4. Okay, I put negative in front because we might as well write down this way, negative 1 over 2 x to power 4 and plus 1 over 8. Okay, and the derivative f prime of x is equal to x to power negative 5 if we take derivative. Okay, so using second fundamental theorem, we are going to get f of x is equal integral from 2 to x squared t to power negative 3 dt, and f prime of x, it's going to be equal x squared to power negative 3, and derivative of x squared, obviously it's going to be 2x also, right? Which we will get 2x to power negative 5, and we get the same derivative. Okay, let me do 2 more and I will be done. So 10, because each one of them it's an interesting case. F of x is equal integral from 0 to x3 sine t squared dt. So it's everything already given. F prime of x, it's going to be equal sine x cubed to power 2, right? And times 3x squared, right? Derivative of x cubed. And this is going to be 3x squared and sine x to power 6. All right. And let's solve the last one. And last one I will solve right here. So f of x is equal integral from 0 to x squared sine q squared dq. So f prime of x is equal sine x squared times 2x, and it's going to be equal 2x sine x to power 4. Yes? Okay. I hope you enjoyed these problems, you learned something, and if you have questions, you know what to do. In the comments, you can put your questions. Okie dokie. See you again.